So in this segment, we look at, B7. It says figure B 7.1 shows two allotropes of carbon. From your knowledge, this is representing, diamond, and that is representing graphite. That is representing graphite. Then it says define the term allotropes. Now, if you remember, allotropes, are different, different forms of the same element, in the same physical state. So we can simply say, allotropes, we are simply talking about different, structural forms of the same element in the same physical state. So different forms, structural forms, that's what we mean, different structural form, but they're both in the same physical state and the same element, just like diamond and graphite. So that's what we call as being allotropes. Then B1 says which of the two allotropes A and B conducts electricity. So it is simply allotrope B. Then explain your answer. We can simply say that it contains, free delocalized electrons that are mobile to conduct electricity. So that's the reason why. So because of the free delocalized electrons, they are mobile, they are able to move to conduct electricity. So that is graphite. A pen such as a pencil, the middle part of the pencil is simply what we call as being graphite. Then Roman 3 says give one difference other than conduction of electricity between allotrope A and B. So they want to give, so we can simply say that allotrope A has a high, melting. It has actually a high, melting and boiling point, compared to allotrope B. The other one that I can simply talk about is allotrope A is harder compared to B, which is soft. So there are so many properties that you could have actually talked about compared to that. In terms of allotrope B, usually this one is actually transparent, that one is actually opaque. So that's what you can talk about. C, give one use of carbon dioxide. So carbon dioxide used in making fizzy, or if you want you can say carbonated drinks. So you can use it in making fizzy or carbonated drinks. Then used in fire extinguishers, so you can also use it in fire extinguishers, it's possible. You can also say used in green houses for photosynthesis. So you are able to use it also in greenhouses for photosynthesis. So this is what we are talking about, and this is what you can do. Thank you so much for watching our videos. If you love what we do, please, you can subscribe to our channel, and you can actually share, so that others too can actually get to learn and revise properly.